quick video on some notes from our latest unit here on coordinate geometry. The first part of our notes, as I make a copy, is going to be reviewing some ideas about slope and equations in particular. So let's take a look at some of these equations. This first one, it says slope is a measure of not distance. You could argue angle, but we're going to stick to the word steepness because steepness kind of talks about a specific type of angle, like from the ground up, or a ratio of a vertical over horizontal. Slope is often referred to as the phrase rise over run, and that's just to try and help us remember in the ratio what part's going to go in the numerator of the fraction and what part's going to go in the denominator. So another way to look at that is that we're going to have a vertical up and down over a horizontal. So there's a vertical there. Let's see if I can click on these correctly. Over the horizontal, which means it's y2 minus y1 on top and x2 minus x1 on bottom. We'll make this a little bit wider so that you can see those just a little bit better. So let's take a look at this picture and see if we can calculate some slopes. I see that I have multiple lines, and I need to find the slope of each of these kind of diagonal lines going on here. I do notice that I could draw like some straight lines, some straight vertical lines, and some straight horizontal lines. If I hold down the shift key, it makes it very easy for me to keep those lines perfectly vertical or horizontal. I look at A and B, and for A, I'm going 2 units rise and then 4 units run. So that slope there, I'll put here as a 2 over 4. That's a slope of 2 over 4. We'll make that a little bit bigger so that it's just more viewable. So that's a slope of 2 over 4. Let's see how we can calculate the other ones. I'll copy and paste this text box so I can move it into these other areas. And we could rotate it to kind of match that diagonal measure there. So C and A. This is interesting because it's very similar. You notice that it has the same rise and the same run. The difference is that this one is a negative. And it's negative if it's going downhill from left to right, and it's positive if it's going uphill from left to right. So those are very close in measure but slightly different. And then I'm going to copy and paste that, and we're going to figure out this purple one down here. This one would also be negative, but the fraction, the division, the ratio here is going to be different. Our rise from A down to D is 3, and our run is 1. Now, each of these numbers, 2 over 4, negative 2 over 4, or negative 3 over 1, could be written as other values that are equal. And so sometimes that just depends on rewriting the fraction in another form or rewriting it maybe not as a fraction. So I'm going to leave those 3 things there. And if it were to ask me what's the slope of AB, I would say that that is 2 over 4. Or you could have said 1/2, or any number that was equal to that. You could have even said 0.5 or 0.5. Any one of those works. For AC, that's the green line. That's the negative 2 over 4, or negative 1/2, or negative 0.5. Any one of those would have worked. AD, this is where we saw that it is negative 3 over 1. But you could also just say, or just negative 3, because when you're dividing by 1, that's the same as writing it as the integer value number. So you don't have to have it with a numerator and denominator if that denominator is 1. All right, let's look at some other types of situations where we might have horizontal lines or vertical lines. Horizontal lines have what we call a zero slope, and the vertical slopes, we're going to say, are undefined. But here's why. So when I try to figure out my rise over run, in particular from like C to D, I don't go up and down at all, but I do go left and right. So when I think about the way that we calculate that with like this type of piece here, to go from C to D, my y value is the same. It's 5 to 5. So I went from 5 to 5, and that's just 0. But for my run, I started at -2, and I went to 5. So I'm going to fill this with -2 and go all the way to 5. Now when I think about this distance, it's 0 over -7, or you could have said 7. It doesn't really positive or negative in this case, but that's just 0. So that's a 0 slope. But now let's say I wanted to go the other direction from A to C. Well, the y values go on top, so my y values are from 5 down to 1. So I'm going to fill this in by clicking on these boxes, and I'm finding a difference from 5 to 1. But for the x value, it's the same. It starts at -2 and ends at -2. So I put a -2 in there, and I'll put a -2 in here. And here's the part where it gets kind of weird, because it's a 4 on top, but on bottom, it becomes a 0. And this is where calculators, nope, can't do that. So to try and divide by 0, that's a weird thing in math that we can't simply calculate it. It kind of requires a different perspective in order to interpret that number. So that means that we just say it's undefined at this point. We don't have a really good definition. So the slope of CD across the top, that was 0, or just the number 0. Slope of AC, vertical, up and down, we're going to say undefined. And similarly, we have AB across the bottom would also be a 0 slope. And the slope of BD is going to be undefined. All right, let's say this is much more common. You know, you're just given 2 points and it says, hey, figure out the slope of these 2 points. Well, let's figure out where they would be. We're going to go from -2, 4 to 1, -2. So I'm going to get my diagonal line, and I'm at -2, 4 to 1, -2. So there's my line. And I notice that my vertical distance, I'll go ahead and draw a line for that, is here, and my horizontal distance is there. So my vertical distance is 1, 2, 3, 4, 5, 6. I could also look at it as 4 above the x-axis and 2 below, and 4 plus 2 makes 6. And then I have a 2 and a 1 here to make a 3. Let's put those numbers in there. So this is a 6. Make that bigger. And copy and paste that. And down here, this is a 3. All right, so how do I figure out this distance? Oh, not distance, this slope, pardon me. We're talking about slope, this steepness that we're trying to do. So I went from my y values, went from 4 minus -2, so 4 minus -2. And the x values went from -2 to 1. So that's -2 to 1. And when I start putting all this together, I would wind up getting 6 over 3, just like we're thinking, but negative. So I want to make sure that it's negative. And in this case, that's going to simplify to just negative 2. So I would screenshot this over here as part of my calculation. And there we go. Let's make it a little bit smaller, make things fit, just nice and neat. Perfect. All right, so that's the idea of like finding slope between 2 points. That's not a big deal. Let's now think about slope in terms of equations. Okay, so this is going to be a little bit different. To find the slope from an equation, first you're going to solve for y, then look at the coefficient. That's the number that's being multiplied. And we're going to look at the coefficient of x. Now, if you click on this here, it will be set up such that you can get to a link. So it brings up a new math.new. But what I can do for this one is I'm going to just type these out, and then we'll work them out. So I'm going to have 2y equals 6 minus 3x for my first one. And what I want to do is solve for y. So how do I solve for y? I'm going to get that 2 by itself. Or that, not that 2, the y by itself. But this means I can divide the 2 into each of these. And now I have a coefficient with x. This coefficient is this number here, 3/2, but it's negative. I could keep it there, or I could put it in front. A lot of times people like to put the x term in front of the constant term. Either way is fine. But that coefficient there tells me that the slope is negative 3/2. So I'm going to take a picture of this. Kind of shows my steps. I'm going to make it a lot smaller though. Probably about that there. And then we will have, we're going to say that the slope equals negative 3 over 2. All right, let's look at this other one here. 10 plus 4y equals 2x. Very similar, very similar. 10 plus 4y equals 2x. All right, so now as I want to solve this one, I'm going to subtract 10 from both sides by clicking on the equal sign. I'll put that 10 and that 10 together. So that gives me 4y equals 2x minus 10. Now I can divide by 4 on both sides. Click on the equal sign, and then I can tell it what I want to do. So 4 divided by 4 becomes just y. And this 4, I can make it divide into both of those terms. And that gives me a 2x, 2 over 4 times the x. And then we got a constant over here. But I'm really interested in this slope right there. So that slope is 2 over 4. So I'm going to screenshot just those kind of 2 quick steps. Paste those in here. And we'll say the slope is equal to 2 over 4. Now you could have said 1/2, you could have said 0.5. Any one of those are appropriate values. Okay, for this last one, it says 1/2 minus y plus 2x equals 0. All right, now what's the point in all these equations? It's to solve for y, or get the y by itself. I could move everything away from the y, but I could also just add y to both sides. And watch what's going to happen here. This minus y and this plus y, those make a 0. And over here, y plus 0 is just 0. I got y by itself. I solved for y. So I can do that in algebra. I don't have to get my isolated variable on the left side. It could be on either side. Since I've done that, I look at the coefficient or the number next to x being multiplied, and in this case that happens to be 2. So again, it's just a little bit of equation solving to get y by itself, and that will reveal to me what the slope for, what the slope for the equation is. So if I paste this in here, and I can say the slope is equal to 2. Just like that. All right, now let's talk real quick about parallel lines and perpendicular lines. Parallel lines have equal slope, and perpendicular lines have something called opposite reciprocal slopes. And I don't have extra examples or practice in here, but I do want you to check the work in Delta Math, and you should be able to find some examples, and you can put them in there as well, just to try and determine which ones are which. We're going to develop this idea of parallel and perpendicular a lot more in the future sections, but that'll do it for this first video.